Cambridge IGCSE Mathematics, Paper 0580, Paper 42. In this lesson, we solve questions 16 to 21. Every method follows the official Cambridge mark scheme, with full explanation. Question 16. A histogram shows the masses of some coconuts. The masses are divided into categories A, B, C, and D. First, show that category D contains 10 coconuts. Then find the probability that 2 coconuts chosen from categories C and D are both from D. Finally, calculate an estimate of the mean mass. In a histogram, frequency is not the height of the bar. Frequency equals class width multiplied by frequency density. For category D, the class interval is from 1.35 to 1.6. So the class width is 0.25. The frequency density is 40. 0.25 multiplied by 40 gives 10 coconuts. Category C has width 0.1 and frequency density 170. So its frequency is 17. Together, categories C and D contain 27 coconuts. For the first choice, the probability of choosing from D is 10 over 27. There is no replacement. So for the second choice, 9 coconuts from D remain out of 26. Multiplying gives 5 over 39. To estimate the mean, use the midpoint of each class as the representative mass. The midpoints are 1, 1.175, 1.3, and 1.475. Multiply each midpoint by its frequency, add the products, then divide by the total frequency, 48. The estimated mean mass is 1.26 kilograms. Question 17. Expand and simplify. X minus 2 multiplied by 2x plus 3 multiplied by x plus 4. We expand 2 brackets first. Multiply 2x plus 3 by x plus 4. This gives 2x squared plus 8x plus 3x plus 12. Combine the middle terms to get 2x squared plus 11x plus 12. Now multiply every term by x minus 2. After collecting like terms, the answer is 2x cubed plus 7x squared minus 10x minus 24. Question 18. OA is parallel to CB, and OA to CB is in the ratio 4 to 3. Vector OA is A, and vector OB is B. Find vector AB. Then M is the midpoint of OC. Find vector AM in its simplest form. To travel from A to B, go from a back to O, then from O to B. Vector AO is minus A, and vector OB is B. Therefore, vector AB equals B minus A. Because OA and CB are parallel and their lengths are in the ratio 4 to 3, vector CB is 3/4 A. To find OC, travel from O to B and then from B to C. Vector BC is minus 3/4 A, so OC equals B minus 3/4 A. M is the midpoint of OC, so OM is 1/2 B minus 3/8 A. Finally, AM equals AO plus OM. This gives minus 11/8 A plus 1/2 B. Question 19. Solve the simultaneous equations y equals 5 minus 2x and y equals 3x squared minus 7x minus 6. Show all working and give both solutions correct to 2 decimal places. Both expressions are equal to y, so we set them equal to each other. This gives 5 minus 2x equals 3x squared minus 7x minus 6. Move everything to one side to obtain 3x squared minus 5x minus 11 equals 0. Use the quadratic formula. The 2x values are approximately 2.92 and minus 1.25. Substitute each value into y equals 5 minus 2x. The corresponding y values are minus 0.84 and 7.51. Question 20. A metal prism has mass 4,810 grams, correct to the nearest 10 grams. Its density is 7.7 grams per cubic centimeter, correct to 1 decimal place. Calculate the lower bound for the volume. Volume equals mass divided by density. To make this quotient as small as possible, use the smallest possible mass and the largest possible density. The lower bound for the mass is 4,805 grams. The upper bound for the density is 7.75 grams per cubic centimeter. Dividing gives exactly 620 cubic centimeters. Question 21. Y is inversely proportional to the square of x plus 2. W is directly proportional to x. When x is 3.5, y is 8. When x is 90, w is 15. Find y in terms of w. Inverse proportionality gives y equals k divided by x plus 2, all squared. Substitute x equals 3.5 and y equals 8. This gives k equals 242. Now use w is proportional to x. Write w equals cx. Using w equals 15 when x equals 90 gives c equals 1/6. So w equals x over 6, which means x equals 6w. Substitute 6w for x. Therefore, y equals 242 divided by 6w plus 2, all squared. Questions 16 to 21 are complete. Remember, explain the method, show every important step, and round only at the end. Presented by teacher Issa Alnobani.